Hello everyone, we continue our tests with the HVD-Orion. Today's test will be with an APM. The model of the APM is EL1100. First, I'll talk to you about its external connections. The APM's electrical connection is made to the communication COM port 3 section. Here, there is a contact power section. At the same time, KEN and RS485 connections are made for communication. The output ports of the APN are connected to the output port sections of the HVD. In order, port 21, port 22, 23, 24, 25, and 26 are connected respectively to the output ports of the HVD. They are connected to ports 7, 8, 9, 10, 11, and 12. The air inlet of the APM, which is port 1, is connected to the input port 4 of the HVD. The input port 2 of the HVD is also connected to the 12th connection port of the APM as shown in the diagram. Again, from the device test section, the segments where the devices are located can be found here, such as EBS, sensor, electromechanical, ECAS, and the APM APU segments. We enter the APM APU section. In the upper left corner, there are many APM model numbers. There are various APMs such as Scania, Mercedes, and Ford. We select EL1100 from these APMs, the one currently connected. Just below, depending on the model of the APM, there are options like CAN Automotive Ethernet, Limbus. It is possible to use different communication methods such as RS485. The current EL1100's communication method consists of CAN and RS485. When the test starts, you will be able to see its connections here anyway. Here you can find the test duration. Just below that, there is a tab indicating the overall test status. Below that, the Prepare section, the Prepare button, ensures that the scenario on the computer, which varies for each device, is sent to the computers inside the HVD-Orion, and with the Start button, the device, module, or APM is operated according to that scenario, allowing the testing of the pressure sensors and the scenario trainings. The test scenario. Again, you can follow the test steps from the test steps section on the right side. You can also obtain these test steps as a document from the Show Report section. Right below that is the DataJet section. This DataJet section contains information pages for modules such as APM, EBS, and sensors from the manufacturers. Right next to it is the Repair Manual section. Again, you can access the PDF version I mentioned in the video from here. Here, you can access information such as air connections, electrical connections, and how to use the computer interface. In a moment, when I say prepare to start the test, the information and pressure data of the HVD-Orion will appear. After that, if a connection is established, the APM voltage coming from CAN, from RS485, the APM. The temperature and the pressure data from the K1, K2, K3, and K5 sensors will also be visible. After connecting the solenoids, we can also control them individually. Different solenoids like the discharge solenoid and the loading solenoid, we can control them individually from here. When I click on the Prepare section, air is supplied to the module and its power and glass connection will be established. Right now the glass connection has been made. There are pressure readings from the APM, K1, K2, K3, and K5 as mentioned. For example, we can activate one of the solenoids. As you can see, we could hear the solenoid's clicking sound. When I start the test, the scenario will begin to run. On the right side, you can see that it is waiting for pressure, opening and closing the solenoids, and reading the pressures. During the test, you can continuously monitor the immersion and the incoming real-time data and information. It finished the silence and reflected the result in the most basic way like this. The status of the solenoid, the status of the pressure sensors inside the AFM is shown like this. You can also see the visual representation. If you wish, you can observe it from here as shown above. You can observe the test result. You can output this, you can take it.